Hello students, welcome to GET 2019 video series. Here we are considering a problem from Computer Science 2019 GET exam. It is given to you that capital Y is a uniformly distributed random variable in open interval 1 6. You have to find the probability that this polynomial expression in X has only real roots. We know that a polynomial expression in X in the form ax square plus bx plus c has only real roots whenever its discriminant b square minus 4ac is greater or equal to 0. Since y is a uniformly distributed random variable, so we can consider y as constants in this polynomial expression. This polynomial expression has all real roots whenever its discriminant 6y square whole square minus 4ac, that means that much, is greater or equal to 0. Further simplification produces y square negative y minus 2 is greater or equal to 0, or we can break them into factors. Y plus 1 multiplied by y minus 2 is greater or equal to 0. Now this is a factor, this is another factor. Product of two factors is positive only when all these factors have the same sign. Hence it can happen that y plus 1 is greater than 0 and y minus 2 is greater than 0. These two simultaneously keeps us y as greater than 2. Again, y plus 1 less than 0 and y minus 2 is less than 0 simultaneously gives us y is less than negative 1. So we can have these two cases, either y is greater than 2 or y is less than negative 1. Hence, for the polynomial expression to have only real roots, we have to find the probability that y is greater than 2, or that means t norm operator that y is less than negative 1. We may note that union is a t conorm operator like or, and intersection is a t conorm operator like and. Okay. Now y is greater than 2 or y is less than negative 1 gives us probability of, there is an additional law of probability of A union B, where A and B are two events. It is probability of A plus probability of B only when the events are mutually exclusive. Here the events y greater than 2 and y is less than negative 1, they are mutually exclusive, they cannot happen simultaneously, and hence this is equal to probability that y greater than 2 plus probability that y is less than negative 1. Since it is given to you that here capital Y is a uniformly distributed random variable in the interval 1 and 6, so we can find its probability density function fy as 1 upon 5 in between 1 and 6, and in other places clearly it is 0. Therefore our probability of y less than negative 1 plus probability that y is greater than 2 implies that we have to compute in between negative infinity to negative 1 fy dy plus integration from 2 to infinity fy dy. Now we may note that fy becomes 0 whenever your y is less than 1, hence we can find that this will become 0. Again, for the second part, we have to integrate in between 2 and 6 for fy. What is fy? It is 1 upon 5, hence the integration gives us 4 by 5, which is exactly equal to 0.8. Our answer to this GET question. Thank you very much for listening. Please subscribe.